Hello, thank you so much for your time today. We are NASA's interns and we are part of the Astronaut Photography Group. Today, we are presenting our research on the hydrosphere and change over time. I'm Klarissa Contreras from Brownsville, Texas.
I'm Kirby Brandon, I'm from Dripping Springs, Texas.
I'm Savannah Behnke and I'm from Brownsville, Texas.
I'm Quinn Hughes, I'm from Minnetonka, Minnesota.
I'm Amelia Jones, I'm from Brooklyn, New York.
I'm Jaxon Morris from Bronx, Texas.
I'm Aparajita Shimpi, I'm from Jersey City, New Jersey.
I'm Villanueva and I'm from Brownsville, Texas.
For this project, we were tasked to learn more about astronaut photography and how it can be used to observe topographical change over time. We each chose 2 unique locations related to the hydrosphere where change over time was observed. For each location, an article describing the observed changes and possible impacts was written. These articles were then combined into a single research project which we are presenting today.
Our goals for this project were to learn more about the changing hydrosphere and how researchers and civilians can use astronaut photography in various ways.
In our approach to this presentation, we used a variety of online public resources given to us by our mentor, Ms. Rossina Miller. Resources included the Gateway to Astronaut Photography of Earth sites that we used throughout our time at SEAS.
For today's presentation, we'll start off with some background information, then we'll dive into change over time, and finish off with conclusions and reflections. First, let's begin with some background information and cover some topics we will be discussing throughout the presentation.
What is astronaut photography? Astronaut photography is photography taken by astronauts. The majority of photos are taken from the International Space Station, also known as the ISS. While on missions, ISS astronauts are asked to take photos of different parts of the Earth, such as lakes, cities, oceans, weather events, and even natural disasters.
What is the hydrosphere? The hydrosphere is the total amount of mass of water on the Earth. This includes oceans, seas, lakes, rivers, groundwater, ice, and snow, and it can be in the form of liquid, vapor, or solid. A healthy hydrosphere is essential for life on Earth, and monitoring it is crucial to climate change research.
What is change over time? Throughout the presentation, we are looking at changes over time, which are changes that can be seen in the Earth's topography, climate, landforms, and any other observable factors. These changes can impact humans, animals, or the environment. Next, we will begin to present the changes over time we have observed in our research.
One major application for astronaut photography is modeling urbanization. In the images to the left, depicting Corpus Christi in 2002 on the top and 2019 on the bottom, one can observe the city's expansion over time. Now, as the population grows, cities must make room. Astronaut photography can be used to model the city expansion. Using astronaut photography, city planners can create safe urbanization through prominent waste management and planned growth. With the expansion of the human population, local agricultural industries are forced to expand and work overtime. The quick expansion of these agricultural industries leads to poor practices like increased use of fertilizers and pesticides. Many local ecosystems, including freshwater and saltwater regions, are impacted as human habitats expand. The expansion leads to habitat destruction and forces communities of animals to disperse. With this hasty growth, many cities don't have adequate waste management, increasing the amount of waste and pollution dumped into freshwater and ocean ecosystems.
Observing the cryosphere, which is all of Earth's snow and ice and a term under the umbrella of the hydrosphere, can tell us a lot about the extent to which climate change impacts our planet. The direct ramifications of global warming decrease glacial ice and snow coverage, specifically at the poles, northern hemisphere, and peaks of mountains at higher altitudes. I focused on 2 locations to contrast snow coverage over the last 2 decades, Mount Fuji and Kilimanjaro. Mount Kilimanjaro is a volcanic massive, a geologically distinct mass of rock, forming the peak of a mountain range, located in northeastern Tanzania, near the Kenya border. Astronaut photography from the ISS visualizes snow coverage differences between 2008 and 2021, both taken during the summer. There are visible distinctions of more coverage in 2008, even after considering climate contrasts. Mount Fuji, the highest mountain in Japan, is located near the Pacific Ocean in Yamanashi and Shizuoka. Mount Fuji is notable for its iconic snowcap. However, in recent years, snow accumulation at the top of the volcano has been dwindling or is absent around the winter season. The images taken on the ISS show a progressive decrease in the snow coverage of Mount Fuji, Japan in January 2001, November 2013, and February 2021. There is a visible change in the snowfall cover that blanketed the entire volcano and surrounding area in 2001 to just the peak and radius around it in 2013, and finally, an even smaller coverage of the peak in 2021.
Sea level rise has been a consistent topic in our lives. However, this is not only a problem for future generations, it will have a measurable impact in the present day, with coastlines expected to rise 10 to 12 inches in the next 30 years. Over 40% of U.S. citizens live near the coast and may be observing slight changes over time. One city that illustrates the change over time caused by sea level rise is Galveston, Texas. Galveston is located on a barrier island southeast of Houston and is part of a chain of islands that go all the way down to Mexico. Both photos were taken around the same time of year and time of day, but 34 years apart. The photo on the left shows a clear and distinct shoreline, while the photo on the right shows a shoreline that has become indistinct due to rising sea levels. This change has happened in only 34 years, and if sea levels continue to rise at this rate, it will have devastating effects. By 2050, it is predicted that many parts of Galveston will be fully submerged underwater at least once a year. This will cause lots of economic stress to fix and adapt to being submerged. But not only this, tourism, one of Galveston's main sources of revenue, will be affected due to decreased beach size. People will no longer have beaches to go to, cruises will no longer be able to dock, and an increase of more powerful storms will dissuade people from visiting. Hurricanes like Ike and Harvey have devastated the Houston area, and the storms like this are only expected to go stronger and more frequent, such as the recent Hurricane Beryl that hit Houston and Galveston area just a few weeks ago. Barrier Islands are supposed to naturally mitigate the damage caused by storm surges, but due to sea level rise, they are unable to. Currently, the city of Galveston has the X-Egg Plan, a 17-foot wall that would surround most of Galveston coast, but costs an estimated $57 billion and will prevent marine animals going to shore and also disrupt tourism. The changes we observe in Galveston can be observed all over the earth and affect coastal communities everywhere, but sea level rise is not the only thing affected by climate change.
Using astronaut photography, we can observe coral reefs and islands that are either too remote to observe in person or are changing too slowly for direct observation. The two photos shown on the left picture Santa Isabel Island of the Solomon Islands. When compared to the clear blue waters of the top image from 1991, the 2010 image shows plumes of tan sediment drifting outwards from the island and thus creating a murky effect. These areas are known as sediment plumes and are caused by rising sea levels that are a consequence of global warming. When the sea level rises beyond the height of normal tides, the ocean picks up extra sediment and drags it out into the open water, resulting in much of the sediment being deposited on reefs that border the islands. In the Solomon Islands, according to the National Oceanic and Atmospheric Administration, also known as NOAA, the sea level is rising approximately 3.65 millimeters per year, which will result in an increase of 1.2 feet within the next 100 years. In fact, satellite images have proved that at least 5 small reef islands have already been covered, and 6 more are on track to disappear. Excessive amounts of sediment will be picked up from this rise in sea level and these disappearing islands and lead to various consequences for marine life. The most significant consequence is the coral reef damage, specifically the coral bleaching that occurs. This happens in one of 2 ways. Firstly, excess sediment can land on top of and smother coral and block it from accessing light or food. And secondly, sediment that hasn't settled will cause murky water, as seen in the image on the right, that blocks sunlight and prevents photosynthesis. In addition to coral, fish and other reef organisms that rely on the safety of the reef will also suffer, as they struggle to find food and shelter from predators. But change over time can also be viewed in freshwater environments, such as floods and droughts.
As a result of climate change, floods and droughts are occurring at a faster rate, to the extent that communities residing close by cannot respond quickly enough. One flood and drought site that exemplifies this circumstance is the Horn of Africa, a region home to the easternmost part of the African continent. Due to the cycle of Niño Southern Oscillations, ENSO, the warming and cooling of the ocean surface as a result of climate change, weather patterns have become imbalanced, leading to an imbalance in the amount and severity of floods and droughts. This has caused areas such as the Horn of Africa to have a large death toll and many of its populations being displaced due to the damage to their villages and decreased livability. Now, one way to clearly see this occurrence is through astronaut photography. On this slide, there are astronaut photographs of an area within the region of the Horn of Africa, located in Somalia, which convey the aftermath of severe flooding. From 2005 to 2007, there was a visual increase in vegetation and water capacity. A dry swamp became a vegetated swamp, and an area of depression became flooded. While this may be portrayed as a benefit to the dry, hot continent of Africa, this is a rapid change that the landscape and communities residing cannot adapt fast enough to. Seen through resulting effects that have led to millions of dollars allocated in disaster response and over 3 million people to be affected to this day. Whether it be droughts or floods, which occur interchangeably in the Horn of Africa due to ENSO, both cause rapid landscape change, harming the region in its entirety.
Currently, salt lakes around the world are disappearing at an alarming rate for a variety of reasons, including climate change, poor agricultural practices, and the diversion of water away from the lake. A prime example of an affected lake is Lake Urmia in western Iran. As soon as is seen in the image to the left, taken in 2014, Lake Urmia has been experiencing severe volume loss. Its water variation is largely caused by the increased population of the local area. This population increase caused a greater demand for water in the region, which diverted previous sources of water that had been used to feed the lake. Beyond population growth, climate change has also contributed to the lake's disappearance, as it has caused an increase in temperature of the lake disproportionate to the global temperature rise, which is increasing rates of evaporation of the lake. The destruction of the lake is detrimental to its diverse ecosystems, which host a variety of wildlife such as flamingos, migratory birds, and brine shrimp. The health of the lake is also critical to the local economy and people, but hope is not lost for Urmia as efforts are being made to help it. As seen on the image to the top left, back in 2022, Urmia regained much of its water. However, it again lost it in 2023, as seen on the image to the bottom left. This change can be accredited to the works of the Iranian government, as well as the global community, as it has come together to begin to bring this lake back from the brink. However, it still is slowly drying up, and more needs to be done to prevent this lake's extinction. Urmia is just one tale in a story of hundreds of vanishing lakes, which are critical to protect and to study as we learn more about the effects of human activity on the hydrosphere.
The Yellow River, located in China, is one of the most sediment-filled rivers on Earth, which is demonstrated by these images. Its banks are very easily eroded as the current swallows up millions of tons of soil every year, and over 2,000 years has altered the coastline by hundreds of kilometers. Noted by Britannica, the Yellow River has flooded 1,500 times since the 2nd century BCE, causing unimaginable death and devastation. There were 3 historical floods on the Yellow River in 1887, 1931, and 1938. These 3 floods collectively killed millions and are considered the 3 deadliest floods in history and among the most destructive natural disasters ever recorded. The primary challenges of the Yellow River can be attributed to reduced rainfall, increased water demand, and overuse from agricultural and population demands. On occasion, the river has dried up before even reaching the delta. The increased usage of the Yellow River is a pressing issue as the river's water pollution problem worsens as the flood risk increases due to the high amount of sediment. At the same time, more sediment makes the water murky and increases the chances of fish gill blockage. Sediment fills the bed of the Yellow River when flows are low, and according to NASA Earth Observatory, the river is already perched above the surrounding floodplain by as much as 10 meters. Now, Brian will be discussing how algae blooms change over time.
Thank you, Quinn. Climate change has significantly altered the hydrosphere, impacting aquatic ecosystems and threatening various organisms due to unpredictable weather patterns like droughts and floods. One effect few know about are algae blooms. Algae is important to the earth, being one of the greatest oxygen producers and carbon dioxide absorbers, as well as providing nutrients and habitats to aquatic ecosystems. Algae can also be harmful to the environment. When harmful algae blooms begin to decompose, a bacteria that aids in the process releases a toxin which extracts oxygen from the surrounding area, suffocating fish. Climate change has caused fluctuations in algae blooms worldwide. Higher water temperatures have increased and decreased algae growth unpredictably. Lake Natron, located in northern Tanzania, is a unique environment with high concentrations of alkaline and volcanic minerals, making it an ideal habitat for algae. The algae in the lake is lethal to most animals except for avian species such as lesser flamingos, pelicans, storks, etc. Because of the rising water temperatures, unpredictable weather patterns have distributed the equilibrium of the ecosystem in Lake Natron. This can be observed in the above image, which was taken in 1993, and the below image taken in 2002. Severe water reduction can be detected in the below image comparison to the above image. This reduction causes the salinity in the lake increase, promoting algae growth. But because of the reduction in water, algae is limited to the area it can populate. The microorganisms in Lake Natron are a crucial food source for the lesser flamingos and other species in the area. With less algae available, the food supply for these birds diminishes, leading to a decline in populations. Through astronaut photography, we can observe these changes over time and understand the full extent of the impact. This visual data helps researchers track the decrease in algae and its ripples effects in the environment, emphasizing the need for conservation efforts to protect the vulnerable ecosystems.
In conclusion, using astronaut photography is incredibly beneficial for studying the various aspects of our Earth's hydrosphere. It is also important to talk about the continuous work and effort being put into research and protection. Using information gathered from satellites, such as the GRACE and GRACE-FO missions, shown on the left and right respectively, groundwork, and astronaut photography, NASA continues to research the hydrosphere as it becomes increasingly affected by climate change.
This knowledge is vital to understanding how our hydrosphere is changing to combat the negative trend better. Astronaut photography, by playing a significant factor in this research, is therefore also essential in protecting our hydrosphere.
Because of this, there are different ways that the public can interact with astronaut photography. The main access point is through the website Gateway to Astronaut Photography on Earth. Here, you can pursue both curated collections and find specific places on Earth using the Explore or Search tab.
Additionally, there are the Where in the World activities created by the Aries Science Engagement Office that allows you to explore the world through astronaut photography. In conclusion of the internship, here are some final reflections of our experiences here.
Because of the mass amount of astronaut photography provided to us, it was difficult to find specific images we were looking for. An additional challenge we experienced was combining our individual research together for the presentation because of their diverse nature. To overcome these issues, we narrowed our search field to the hydrosphere and practiced navigating the gateway to astronaut photography until we found the correct data.
Regarding NASA SEAS, we want to mention how impactful this internship has been. SEAS allows us to network with excellent professionals in the fields of our interest and collaborate with peers from diverse backgrounds to explore a joint passion for space and learning.
One of the most memorable parts of this trip was getting to know and get close to people from all across the nation. The friends and connections I made along the way made the trip one I remember forever. In the photo, it shows me and my team when we decided to paint and play games together after a long day of work.
This experience has provided us with such an amazing opportunity to work with and under the guidance of professionals who genuinely care for us and our success.
An amazing part of my experience here at UT Austin was visiting the Aerospace Engineering and Engineering Mechanics Department. Visualizing and listening to workshops and projects I would possibly participate in was exciting to hear and helpful towards the visions I have for my future.
My favorite aspect was meeting with a real-life astronaut. This is Dan Tanney, who was an astronaut aboard the ISS.
The most memorable experience for me was when we visited the Johnson Space Center in Houston, Texas, and were allowed to tour the different buildings, as touring a NASA facility is an experience I would have never had back in New York.
The research and experiences at the Center of Space Research were definitely an adventure. I enjoyed the many speakers, experiments, and teamwork activities hosted there. The image I selected was one of my favorite experiments dealing with microgravity.
My favorite part of this program was our time together as a team at iFly, an indoor skydiving experience where SEAS students learned about the aerodynamics of wind tunnels, were able to calculate their terminal velocity during our flights, and of course, indoor skydive.
The most memorable time I've had here at SEAS is when we went to Fiesta, Texas. While at the amusement park, interns were tasked to perform their chosen experiments with the Z-Cube we had been learning about, basically collecting data on how microgravity affects our experiments while going on all the fun rides.
Firstly, we want to thank Ms. Rossina Miller from the Johnson Space Center for guiding us and giving us insight on how researchers work at NASA.
Next, we would like to thank Margaret Baggio, Selena Miller, and the rest of the NASA SEAS team and Center for Space Research for giving us this opportunity to work and research as interns.
Lastly, we would like to thank Flor Gomez for guiding us every day and supporting us through our work.
Thank you all for coming and giving us your time today. We will now be opening up the floor to questions.